Hello, this is Nick of Time. Welcome to this, our 26th talk. Today we're going to be going off on a little bit of a tangent and away from looking at the physics of time, and we're going to look at a very general question. Is more critical thinking needed in modern physics? This talk is labeled part 1, and the next talk is labeled as part 2, but actually they can be seen in either order. Part 1 will focus on Wrinkles in Time, which is a topic of cosmology and the Big Bang. But rather than detailed specifics of the theory, we're going to look at the issue of critical thinking and is it applied. It seems that establishment thinkers think of accepted theory as facts, whereas to be a critical thinking, you need to be open to analyzing what's considered as a fact to see if there are any flaws in it, and also open to better alternatives. Okay, today we're going to be looking at something that's called the greatest discovery of the century. And actually, the next talk will also look at another discovery that was claimed by many to be the greatest discovery of the century. So two very important topics. On this topic, my casual views on Wrinkles in Time will be presented, where Wrinkles in Time is a topic of cosmology and the Big Bang and the physics of the super-large. The next talk will be Professor Unziker, who's an expert on particle physics, and his views on problems associated with the alleged discovery of the Higgs boson. And this involves physics of the super-small, the other end of the spectrum. Well, even though the two topics look at the opposite ends of the physics spectrum, it seemed like there were common pitfalls for both of these very different areas of modern physics, and that's why I'm doing this two-part sub-series here. Okay, let's look at Wrinkles in Time. It's the title of an excellent book by George Smoot, who is an excellent scientist. The book describes what many have called the greatest discovery of the century, and in fact it won the 2006 Nobel Prize. Unlike special relativity and some of the issues on time that I've studied for decades, this is an area that I've not studied other than reading this book. But as I read, certain things jumped out at me as seeming like they needed more critical thinking. And then, when years later I saw Professor Unziker's views on the Higgs boson discovery, it seemed like my views matched his views. So that's what this two-part series is all about. Okay, a little background on Wrinkles in Time. Wrinkles in Time is about analysis of the cosmic background radiation, which we'll abbreviate as CBR. One of the discoveries of analyzing the CBR is that our galaxy is moving towards the so-called Great Attractor. So the radiation from the CBR is blue shifted when we look in the direction of the Great Attractor, and when we look at the opposite direction, where we're moving away from another part of the galaxy universe, it's red shifted. And this finding has been pretty well established. Second, the temperature profile of the CPR maps exactly to a black body radiation profile. And this really is consistent with the Big Bang theory. The Big Bang says that the CBR is the remnant radiation from that initial Big Bang, and it's been cooling down ever since. So, where you have a major explosion, generation of a lot of heat, you would expect that remnant of the Big Bang, the CBR, would give off radiation that would match the typical black body radiation profile. So that was considered a point supporting Big Bang theory. The third finding was the extreme uniformity of the CBR. Wherever you looked, as long as you took into account that we're moving towards the great attractor and adjusted for those wavelength shifts, you saw extreme uniformity. Now, unlike the prior bullet, which tended to support Big Bang theory, this presented a problem for Big Bang theory. And we'll look at that. Okay, the problem is that since a Big Bang is supposed to produce extreme uniformity, how did structures like galaxies, galactic structures, the Great Wall of Galaxies, form in our current universe? How can you get a highly structured universe starting with extreme uniformity? So, the issue was to look in the CBR, the early signal from the Big Bang, to see if you could see patterns that would suggest future structures. And they were hoping that it wouldn't be complete uniformity without any patterns. And those patterns were called wrinkles in time. Well, part of the answer to the Big Bang problem listed above was an invention called inflation epoch, where the universe, after a tiny fraction of a second, would suddenly increase its rate of expansion and expand by a factor of 10 to the 50th power, where that little caret indicates that the 50 is an exponent. And 10 to the 50th is a huge number, really beyond our imagination to even contemplate. And that huge expansion is supposed to have happened in the tiniest part of a second, 1 part in 10 to the 34th, which is another huge number of a second. So that's an unimaginably small part of a second, a humongous expansion in the tiniest fraction of a second. So, at least for me, that made this inflationary epoch seem like kind of a not credible invention. Well, in addition to the inflation epoch, one also needed those wrinkles in time in the CBR. Again, the CBR is the remnant radiation from the Big Bang, so they wanted to see some kind of patterns in that early radiation. Okay, so in reading about this, there were some needs for critical thinking, and they happen to be the same ones that Unziker articulated in studying this alleged discovery of the Higgs boson, and I'll use his labels for these needs. There's always a signal illusion. What that means is the equipment generates absolute tons of data that has to be massaged by a computer, and it's manipulated by the software, and noise is eliminated, and other massaging is done. And eventually, if you get down to the lowest levels of analysis and sensitivity, you'll always find a signal. And you'll tend to think, this is the signal I've been searching for. Well, that's true of the Wrinkles in Time. There was tons of data. Years of daily accumulation of CBR data, and each day produced a tremendous amount of data. Now, early on, many cosmologists and relativists first thought that the desired wrinkles would be seen at just 1 part in 10 in the radiation. But as time passed, they couldn't find it in 1 part in 10, or 1 part in 100, or 1 part in 1,000, or 1 part in 10,000. Eventually, the wrinkles were found at the very limit of possible analysis at 1 part in 100,000. So there you have 5 orders of magnitude to play with to call it a success. That's a pretty wide margin. If you got lower than 1 part in 100,000, then you're having the signal being quite a bit less than the noise, and that's not a very credible discovery. Okay, last bullet. All that data was massaged by a lot of software, analyzing and looking for patterns. And to do that, a great deal of noise had to be removed. Noise from our Milky Way galactic radiation, noise from our instruments, experimenters' instruments, and the software itself could produce fake patterns. Have to get rid of those. And go into a little bit of deep detail here. The dipole, which refers to the evidence that we're moving towards the great attractor, where we have a blue shift in front of us and a red shift behind us, that has to be accounted for. And secondly, there's a quadrupole that the Milky Way galaxy produced, and that had to be removed. And lo and behold, when that quadrupole was removed, a much fainter quadrupole that had exactly the same orientation was found, and that was the beginning of the finding of the wrinkles in time. So the next critical thinking concern was labeled by Unzicker as suppression of basic problems. And I think he meant by that there have been a number of problems in physics that have just sort of been ignored. But I take a little bit different look. What I see often is happening is the problems are addressed, but they're addressed by bridging the gap between theory and data. And if there's a gap between theory and data, that's a problem. They bridge that gap by inventing fudge factors. And my first impression of inflation was exactly that. It's just a fudge factor. And I put in parentheses dark fudge factors because we have dark matter and dark energy that were invented to bridge the gap between what current theory projected and the data the empirical data. For example, dark matter was invented to explain the gap between observed galaxy rotation rates and what general relativity predicted. So there was a gap between the data and the theory that needed a bridge, and dark matter was that bridge. And inflation was invented to explain the universe's high degree of structure from the original theoretical homogeneity of the Big Bang. Okay, the third critical thinking concern was called theoretical wishful thinking. Smoot had been searching for wrinkles for 18 years, using weather balloons and then the U-2 spy plane outfitted with special equipment, and finally the Kobe satellite that was launched by NASA. So for him, and just reading his book, he's pretty explicit about it. He's hoping to find the wrinkles. He's thinking that not finding the wrinkles would be failure, and he mentions that over and over again. Whereas if you find the wrinkles, that's equated to success. You're confirming currently accepted theory. So you get success, celebrations, parties, prizes, and you're a hero to your peers. Now, Smoot's peer group would present a lot of peer pressure, because the peer group, as individuals, had all spent their careers on studying, analyzing, teaching, writing about accepted theory. So their careers basically go down the drain if those theories are disproved. Now I'll repeat that last bullet because it has another effect. Not only does it present peer pressure on Smoot himself, but it defines how that peer group is going to receive information. If it receives information that their theories are confirmed, that makes them very happy, and they welcome that and readily accept that message. On the other hand, if they get a message that their theories are going to be overthrown, they're going to be very skeptical, might tend to ignore that or just poo-poo it dismissively and accept any counter rebuttal to what's presented negatively. Not only is Smoot supported by his peer group in the search for finding wrinkles in time, but he has the whole world really supporting this effort. Besides his university supporting the Kobe satellite mission to search for wrinkles in time at a higher sensitivity, it's supported by NASA and government grants. And it cost over $160 million to do that mission, and over 1,000 people contributed. Now, Smoot's team was not 1,000 people, it was a handful of people. But the talents and expertise of over 1,000 people were required, hundreds from NASA on building the satellite and setting up the rocket that was taking the satellite, and other people designing the experimental equipment that would be used. So it was quite a large effort. And in contrast, dissidents and critical thinkers, independent thinkers, don't have access to those resources. So everything is sort of slanted in the favor of the success for the search for finding wrinkles. And we don't have an equal counter effort to show that, hey, there really aren't wrinkles. Okay, and the final critical thinking concern was the lack of transparency. On the one hand, Smoot is a very honest guy, high integrity scientist, very diligent about looking for errors and trying to make sure that the signals he sees are in fact valid signals, valid wrinkles in time. But he recounts that his team and a third-party error checker had all signed off on announcing wrinkles when Smoot called for one more round of checking, and as it happened, it was discovered that it was just an instrument error that was producing these false wrinkles. However, if Smoot had not been so extremely diligent, it could easily have been a false find. It slipped by a lot of experts and been announced, and I would contend that the acceptance and everything that happened after the real announcement would have taken place. A Nobel Prize would have been awarded, lots of parties, celebrations, and acceptance, and not a lot of motivation to go in and check and see if there might have been an error. Certainly, Smoot, to his great credit, had realized that because he and his team had been working so long to find the wrinkles, that they might be psychologically predisposed to finding them and accepting false signals. So he brought in this third party guy who would take a objective view and was an excellent error checker. But even he, who had found many errors, had missed this one error. So it's a tricky business. And the final bullet, even if the data is valid, the question of is the interpretation justified? For example, Smoot in his book claimed confirmation of not only the Big Bang, but inflation theory and dark matter. So I think there's a big jumps there, because you have wrinkles, but I don't see that he can point to one wrinkle and say, you see, this wrinkle turned into the Great Wall, and this wrinkle over here, that's turned into our Milky Way galaxy. So it is somewhat of a jump even to go into the Big Bang, and it is an even greater jump to say that it confirms inflation. Remember, inflation had that huge expansion in a very short period of time, and that inflation was to take quantum fluctuations, which are very small, and increase them by a factor of up to 10 to the 50th, so they could indeed be valid seeds for the later structure of the universe. And dark matter was alleged to be confirmed because they had gotten down and were approaching 1 part in 100,000 and not finding these wrinkles. And that brought them beyond the limit of current Big Bang theory. So the Big Bang theorists had to do some work, and they added cold dark matter to the Big Bang, and that allowed 1 part in 100,000 to be an acceptable sensitivity level for finding wrinkles in time. So that was considered by Smoot to be a confirmation of dark matter. I think that some skepticism in analysis is in order there. I don't throw these things out just dismissively, but I think there's a need for further investigation, particularly if it's labeled one of the greatest finding of the century. Shows it's very important to be correct. Okay, that's part one, and hope you can join us for part two next time. Thanks very much.